This lesson is going to cover the basics about what exponents are, how to write them, and how to read them out loud, as well as get into a little bit about exponents and grouping symbols, which is a common mistake even for students in higher level math. An exponent is a way to write repeated multiplication. So a way to write repeated multiplication. Now you're already familiar with this concept. Multiplication. That, my friends, is the word multiplication. So you're already familiar with this concept from what multiplication is. So for example, if you had 4 plus 4 plus 4, you learn in elementary school that you can write that as 4 times 3. And so multiplication is a way of writing repeated addition. Then exponents are a way of writing repeated multiplication. So for example, suppose you had 4 times 4 times 4 times 4 times 4. Well, that is 4 written 5 times. Now you don't want to consider how many multiplication symbols you have. And that sometimes is a little bit of an issue with my Algebra 2 students when you go to defining it. It's actually defined as how many times something is used as a factor. And so you're counting 1, 2, 3, 4, 5. And so the way you would write that as an exponent is you would write a regular 4, and then you would write 5. The 5 would be what's called a superscript. So it's written smaller and slightly above. And it's important that you get that right. And I tell my students all the time, if they get lazy about it, so they start out writing their exponents, and their exponents get bigger and bigger, and then what happens eventually is, I say, it gets too heavy and it falls down. Okay, so you want to make sure that your exponent is written smaller. Now there's some vocabulary here. Whatever is being raised to the exponent is called the base, and then the exponent is often called a power. Okay, and that's going to get us into how you say these out loud. A lot of my students don't know how to read it out loud, and so when they want to ask a question, they kind of trip over the words because they don't know how to read that expression. So they might say stuff like 4, 5, or 4 with the little 5. And we want to make sure that we say that correctly. So there's a bunch of different ways you could say it. So I'll give you a couple of examples because we have a couple of shorthand ways to say it as well. So we'll start with this one. We'll say 4 to the 6th power. And that's pretty much the only way that we would say that. We would say 4 to the 6th power. I went to graduate school with someone from another country, and she spoke English, but it wasn't like American English, and so she would say 4 to the power 6, or 4 to the power of 6, where Americans might say 4 to the 6th power. I obviously knew what she meant when she said 4 to the power 6. But if you're in the United States, you would say 4 to the 6th power. Then you could have something like this. Okay, now there's 2 different ways you could read that. You could say 5 to the 3rd power, or we actually have a shorthand for that. We would say 5 cubed, and there's an actual reason for that. Okay, so we would say 5 cubed on that, and it actually has to do with a cube. Not that that's a great cube. That's more like a rectangular prism, but we're not gonna pick that apart. And then here's one more example. Okay, you could say this as 7 to the 2nd power, or you could say 7 squared. And you might be familiar with that from pre-algebra, middle school math, when you're introduced to the Pythagorean theorem. A lot of times you'll be introduced to that vocabulary there. Okay, now what about a power of 1? So suppose we had 5 to the 1st power. Well, think about the definition of exponents. It tells you how many times something is used as a factor or expresses repeated multiplication. So if you had 5 to the 1st power, it would just be like 5. And so most of the time you don't see an exponent of 1 written, but you do want to be aware that it's there. Because when we get to operations with exponents, you'll be working with a 1 and not with a 0. So sometimes students will be like, oh, I don't see 1, so it must be 0. Well, no, not necessarily. So it is a 1 there, so you just want to keep that in mind. So we'll work through a couple of examples just so you can see what you might be asked to do with exponents. So the first example we have is, suppose you were given this and you were asked to write it as an exponent. So that's repeated multiplication. And so that's a waste of space. So how could you write that? So you would count up how many 2's you had used as factors, and we went over what that vocab was in the last lesson. And I can see that there are 5 of them, and so you could write that as 2 to the 5th power, and you could simplify it as 32. Okay. Now, whether or not you need to simplify it really depends on the problem that you're in. So we have exponents for a reason. And so if you've got something that's going to end up being this huge number, I usually tell my students, leave it as an exponent, because that's why we have exponents, so you don't have to write it out. But a lot of times if your answer comes out as an exponent and the number is actually pretty small, like 32, I would encourage you to write the 32. It just is a little bit more user-friendly. So let's use some of our skills from the last couple sections. So suppose you saw a problem like this. Evaluate x to the 3rd when x is equal to 5. So we want to just review that vocabulary. One of the things about math is that you can't just do one lesson and then forget about everything that was in that lesson. So last class we went, or it was 2 classes ago. No, last class. I don't remember what lessons I'm recording. But we went over the vocabulary word evaluate. And evaluate generally means to plug in and simplify. So when you see that word in a future section, you need to be able to go back to that definition, which means that you need to handle the word, practice it, see it, hear it, and so forth. So evaluate means we are going to take out the x and we're going to plug in a 5. So instead of x to the 3rd, we would say 5 to the 3rd. So you can do this out by hand, you can use a calculator, but we'll go ahead and expand it. We want to remember what that 3 means. That means that 5 is being used as a factor 3 times. So we have 5 times 5 times 5. 5 times 5 is 25. And then it might help you, if you want to do this in your head, to think of money. So a quarter is 25 cents. So how much money would you have if you had 5 quarters? Well, you would have $1.25. We just wouldn't have the decimal point in there. Let's do another one that has multiple variables in it. So suppose we'll have another evaluate. And our expression this time is going to be 3a plus 6b all squared for a equals 1 and b equals 2. Now, notice when I read that out loud. So with math, most of our communication in math is done by showing the work that we do for a math problem. But a lot of times, especially if you're a teacher or you've got a tutor and you want to communicate, you do need to be able to say the expression correctly. So when I read this out loud, I said 3a plus 6b, and then I put the word all, okay? And I said all squared. And that all was a verbal way of conveying those parentheses. So we'd say 3a plus 6b all squared. When you were dealing with b's, keep in mind that b's sometimes look like 6's. And you can tell by looking at mine, they kind of look a little bit alike, maybe a little bit too close for comfort, but hopefully you're paying attention to this. So we're going to follow everything that we've built on so far. We're going to take out the a and plug in a 1. We're going to take out the b and plug in the 2, and then we're going to do our operations, follow our operations inside the grouping symbols and so forth. So we have 3 times 1 plus 6 times 2 all squared. Now inside the parentheses, we do start with multiplication. So we're going to start with 3 times 1, and then we can go ahead and do the 6 times 2 at the same time. So 6 times 2 is 12. And then 3 plus 12 is 15. Now, at that point, I don't need the parentheses anymore. You could do that, but those parentheses aren't doing anything because there's only one thing in them. So once there's only one thing in it, you don't need them. And so we can drop the parentheses off. And then, of course, engaging the definition of exponent, that would be read 15 to the second power, or 15 squared. And that means 15 times 15, or 225. Now, let's talk a little bit about calculators. When you end up with very large exponents, well, let's go back to addition. Most of you, I hope, if I were to give you some problem like this, okay? I don't even know what I'm doing here. And I would say do this out on your calculator. I hope that you would not do 5 plus 5 plus 5 plus 5, yeah, and maybe you would, and you could get the right answer that way. But we have a better way of doing it, and the better way of doing it is to find out how many 5s you have. So 1, 2, 3, 4, 5, 6, 7, 8, and we would say that is 5, 8 times, or 40. So I hope that, even if you didn't think of it on your own, that now that I'm saying it, you say, oh yeah, that would be a better way to do that repeated addition. Because what can happen on your calculator is you start typing in 5 plus 5 plus, all those 5s, and then you lose count of how many you've done. And the same thing can happen with exponents. So if you had something like 6 times 6 times 6, we'll go out, we'll do 7 of them, and you start typing them in your calculator, you could actually lose track of how many times you've typed the 6 in, and then it's a lost cause. So just like your calculator has a multiplication button to help you with the addition, your calculator probably, unless you have just a 4-function calculator, but any kind of scientific calculator has a button on it that will help you with your exponents. So just for reference, the button you're looking for would probably look like one of these. It could be a little x with a y as the exponent. It could be the other way around, like a y with an x as an exponent. That's pretty common. And then the other really common one is this. It's called a caret. And you'll actually see that one in printed stuff a lot. Now, the keystrokes for being able to use those buttons can vary, but most of them would go something like this. If you wanted to do 6 to the 7th power, you would type the 6, then you would type whatever the button is, then you would type the exponent, and then you would do equals or enter or something like that. Your calculator might be a little bit different. A lot of calculators nowadays also, when you type it, it'll actually show you the exponent on the display, which is really nice. Okay, and this is some horrifying number, 279,936. Okay, but just a little word about calculators there. Now, the last thing, well, there's 2 more things to go through, is with the grouping symbols. And this actually came up in my Algebra 2 class really recently. It had to do with a negative, and we haven't really gotten into negatives yet in this video series at this point when I'm making this video. But it's the same idea. So suppose you had 2x to the 4th, and then you have 2x to the 4th. Okay, now what you might have noticed is that when I read those out loud, I read them the same way. And that's a big part of it, is they read the same way. And when you're reading it in your head, you'll probably say them the same way. 2x to the 4th, 2x to the 4th. Now, sometimes with this one on the right, you could say 2x all to the 4th, and that helps to put that word all in. But they actually do mean different things. The exponent only goes with whatever it's attached to. So in the one on the left here, and I hope I said right earlier, I might have gotten a left, right, backwards, and I can't rewind it to find it. So on the one on the left, the exponent is only attached to the 4. So that's 2 times x to the 4th, which when you expanded it would be 2, and then you'd have the x 4 times. And you notice I threw out a little vocabulary word there, the word expand, okay? And that's what you're doing when you kind of stretch your exponents out. And so in that one, it's only the x that's being raised. On the one on the right, the 4 is actually attached to the parenthesis, which means that the parenthesis is what is being raised to the 4th. So this one is actually 2x times 2x times 2x times 2x. Now, all of that is multiplication. So inside each of these is multiplication, and then you've got multiplication in between them. And so you could actually write that as 2 times x times 2 times x, like so forth. Okay, did I get that right? And so we have 2 times 2 times 2 times 2, which is 16x to the fourth. Okay, they are not the same thing. And I hope I didn't throw anybody off with using an x there instead of using a number. Like the example that I was taking it from had a number plugged in, so I was just doing that with the x. And my exponent did get a little bit big there, which is, I kind of cautioned you about that earlier. Let's make sure that looks like, make sure it looks like an exponent. Okay, last little piece of instruction, and I wanted to come back to like, where would we use this? Where might you see exponents? And I said earlier we have a shorthand for like something cubed, and the volume of a rectangular prism is length times width times height. So a rectangular prism is something that looks like this. Yeah, okay. Close enough. Okay, like usually I do those much better. And you would take your length and your width and your height and multiply them all together. Well, if the object is a cube, okay, so let's see if I can do it a little bit better this time. All right. Then the length, the width, and the height are all the same. That's the definition of a cube. And so instead of calling them like length, width, and height, we'll just call them like side, side, and side. And when you go to do your volume formula, instead of length, width, height, it's just side times side times side, which would be side to the third power. And so that's where you get the idea of the third power being a cube. So on the next slide, I'm going to put some practice problems so that you can practice the concepts from this lesson, and you can pause the video, do that, and then we'll talk about them briefly at the end of the video. Okay, so I picked 6 problems just for you to review. So the first one is to write it as an exponent. And this is that vocabulary fluency with the language that is really, really important. It's not just about being able to, solve something and get to the right answer. So the first one is 2 squared. The second one is 9 to the y-th power. And the third one is a times a times a times a times a times a. So write all of those as exponents. The fourth and fifth one are evaluate. So going back and using that, evaluate the algebraic expression. A squared minus 3, evaluate that when a is equal to 3. And the second one is 2a in parentheses all squared minus b if a is equal to 4 and b is equal to 10. And for the sixth one, find the volume of a cube with a side length of 6. So go ahead, pause the video, and then once you've had a chance to work these out, you can unpause it and we'll talk about the solutions to these problems. Okay, so hopefully you had a chance to work those through. I'm going to work them out on this space over here for the most part, just so that we can continue seeing what the problems are. So 2 squared would be written as this, 2 squared. And remember, squared is that shorthand for the exponent of 2. So 2 squared. The second one, 9 to the y-th power. I tell my students this all the time. Math is consistent. The rules are the same. So just because somebody changes up how a problem looks, it doesn't change any of the principles and rules for how the algebra behaves. And so that's why it's so important to know what the rules are. So just because you have a variable in there, like a y instead of a number, it doesn't change how anything works. So 9 to the y-th power would be 9, and then the exponent would be like a y. okay, or the power would be a y. And then for the third one, you pretty much need to count how many a's you have there. So we have 1, 2, 3, 4, 5, 6, and so that would be a to the 6th power. So if you got any of those wrong, make a correction. And if you kind of let that to the yth power throw you off, just take some encouragement that you don't want to let that throw you off. All right, number 4, evaluate a squared minus 3 when a is equal to 3. So I'm going to copy down the problem, always good form, and then I'm going to take out the a and put in a 3. And you want to be able to see that, see the substitution. So now we'll start with the exponent. 3 squared is 9. And then 9 minus 3 is 6. I know I'm beating a dead horse here, but top down, top down, top down. Every piece is going to show where it came from the line above it, and anything you're not working with is going to just come down on the outside. Next one, we have 2a all squared minus b, and we're going to take out the a and plug in a 4, and we're going to take out the b and plug in a 10. Start with your parentheses. 2 times 4 is 8. You do not need the parentheses after you have the 8 because it's just an 8. 8 squared means 8 times 8, so that's 64, and then 64 minus 10 is 54. And again, top down, top down, top down. If you're not doing anything with the plus 10, it just comes down the next line. If you're wondering, where did you get 8 from? Look right above it, okay? That's how your work should flow. Last one is find the volume of a cube with a side length of 6. So you probably need to go back and just look up that formula. It's s to the 3rd power. The side length is 6. And so this is going to be 6 times 6 times 6, which is going to be 216. And we did not have any units on that. But if we had units like centimeters, then our units would be centimeters to the 3rd, and it would come right out of that same formula there. So hopefully you feel pretty confident on that. Go back and rewatch anything you need to rewatch, and I'll see you in the next lesson.